They are constrained by low reliability, storage, higher cost, and transfer technology. Measures such as energy conservation, energy efficiency, and clean and green energy technologies in the entire energy supply chain have to be adopted as advocated in the International Energy Management Standard, ISO 50001. In addition, research, development, and deployment of smart, clean, and green energy technologies need to be accelerated. Smart grids, microgrids, smart meters, data analytics, artificial intelligence, and digital twins have a crucial role in the efficient management of the power and energy sector. What strategies can, therefore, be adapted, and accelerated for an energy transition towards net zero vision is the theme of this presentation.
Yeah. Thank you very much. This was a recap what the research we are now doing and where the direction should be. I'm sure this symposium is focused on these issues. And that is why I was mentioning at our IoT and AI and IoT conference, AI and IoT has a tremendous role to play in this also. Okay. I have to start again. Okay. Now question arises now, how to make these sustainable development goals net zero. Everybody is talking about 17 sustainable goals. And originally the idea was to meet the needs of present generation without compromising the needs of the future generation. That was the original idea. But to make it net zero, one more component needs to be added. And I have deliberately put here, as you can see, needs, not grades. Okay, whatever is needed must be done, but just they want to make multi-billion dollars, no way. Then it will not satisfy net zero goal. So needs, yes, not greed of current generation, as well as future generation without compromising the needs, without compromising it. And if we do that, then and then there is a scope or hope for making net zero. Emissions minus absorptions can go for net zero. This is how we can make the sustainable development goals and net zero goals. Okay. And there is a systematic process in ISO 50001 and series, we call energy management systems. First thing first, I think you must have heard, okay, I will later on tell you, there has been some commitment. First thing first, presently we are dominated by fossil fuels. We like it or not. Okay, it was there for last 30 years, till it is continuing. And I'm told they are in big numbers here again in for COP28 to maintain their presence. If you want to shift towards net zero, first thing first we should do is conservation, energy conservation measures, which requires behavioral change. Not easy, not easy. All of us are used to some kind of lifestyle. It is difficult to change. But experts have found that almost 15% of our energy consumption can be reduced by our behavioral change, energy conservation. What it means is now our energy demand from 100 goes to 85. Then comes our engineering, management, and technology process, research, entrepreneurship, wherein we can further reduce energy consumption by another 25% using energy efficiency technologies which are available. They say low fruit hanging one, and the new ones are coming. If we adopt both of them, which might take from 1 to 5 years at the most, if we do it properly, our demand will reduce from 100 to 60. That itself will reduce tremendous amount of greenhouse gases, 40%. And once we are reached here, we have got saving from here, then we can invest in renewables here. We are not saying don't use renewable. Yes, but if you try to do that 100 versus another 100 renewables, that is where we are stuck. Huge investment is required. Reliability is the issue. But if we follow this process, then whatever we save here, invest in renewables, our demand from the fossil energy will go down further. And if we continue this process, by 2030, we can definitely come over here. They are talking about 2030 is here, 50-50. They're still talking about 50-50, 2030, 2050, okay? And then if you continue here, all the way sustainable, only less emergency supply can be taken from the fossilized one. Predominantly the green technology, and if possible, go 100% in future. This is a systematic process which all of us need to follow. Unfortunately, everybody wants to talk about what is media wants to listen, what is everybody wants to dance around. They say, oh, let us go for renewable immediately. And we are finding it tough to get it. $1 trillion are not coming. But we can do it. If this is the 1 week follow it, and I'm very happy, all of you must have read from the news now, COP28 have done the pledges, okay, top leaders have done some pledges. They say they want to double energy efficiency, doubling energy efficiency. At present, only 2% maximum they can get 2022. 2 to 4%, tremendous saving. Every year, double that, okay, try to double it. This is the one pledge they have made it. Hopefully, policies and practices will come accordingly into every nation's activities, planning, as well as industries. Tripling renewables. Though the renewables are increasing, but what is happening is our demand is increasing. As a result, percentage of renewables are staying at almost 10, 15, at the most 20%. Percentage will almost stay same, unless we do something about it, okay? And that is what I mentioned it. So these are the challenges. Do you want to triple it? Reliability issue, how we can resolve it? That is one challenge. Economics will be another one. And technology, that is where the research is very important aspect. And we are very happy for the symposium. We have got academic track where you will be discussing about some of your findings, how we can go towards sustainability and net zero. And obviously future possibilities for this, we need the industry's support. We are looking forward for the panel discussions, how you are going to help us in future. So this is exactly what is the important theme and preamble of IEEE, GreenTech, Sustainability, and Net Zero Policies and Practices Symposium. I'm very happy. This is a team. This is a teamwork, and it is possible. International collaboration is possible. We are showing over here. So I'm thankful to all those who came here. Some of them are already here. Some will be coming tomorrow. Some will be coming online and addressing. So please give them a big round of applause, okay? And Dr. Sarah, who is also helping us. We have got a young team. Dr. About, I think Engineer About will tell them about more about organizing team from Dubai, Egypt, and Lebanon, how they are coming together and helping, and all the way from Singapore also, okay? Academic track, almost 50% acceptance rate. Okay, so though we issued more than 50, we could only select based on reviewers. So thankful to the review people, those who reviewed it systematically. We had 2 blind reviews, and based on that, they selected 50% of that. Industry track, we received several submissions. I think team has selected around 8 to 10 topics on this one, in addition to the panel sessions, okay, presentation. There are around 27 speakers, 4 keynote speakers are there. I'm very happy to, is there updated number? 27 was the last time you got it. 27 countries are participating. Give them a big round of applause, okay? And we are happy, we are alongside, aligned with the COP28 in Dubai, okay? UAE. Just to closing one, the future, it is the future. I wrote it sometime 2020, August 2020. when they are discussing about net zero, I say net zero pollution, net zero waste, net zero energy at its best. Net zero pollution, net zero waste, net zero energy at its best. Make them part of everyday routine. Not only one time, okay, not on Earth Day, not on some other day only, everyday routine to keep our surroundings clean and green. You can share it with anybody, no copyright for this. Okay, if you like it, make a photo and share it. Okay, otherwise ask Sarah, she will share with you. This is the vision. This is the vision IEEE TEMS, okay, is promoting for synergizing green tech, sustainability, and net zero. And this is our first effort. This will not be the last effort. Okay, so every year we will continue our effort, maybe double it, triple it, okay, as expected there. This is the vision we are promoting. Thank you very much. LinkedIn, you can join us. We have got also Facebook for GreenTech especially. This is Deepak Vaikar bringing you back in this hall of Holiday Inn, okay, Festival City, to discuss more about green technologies, sustainability, and net zero, okay? So I welcome you all, and I look forward to interacting with you. Myself, I will be available for today and tomorrow. I'm very happy our top leadership is also here to support this one. And anything you want later on to interact with us, feel free. All of you, welcome to Dubai. Okay, welcome to Dubai, welcome to UAE. And make full use of this symposium. This symposium, not only to listening to the presentation, but also networking it. So make full use of it. So thank you very much for giving me opportunity to serve on this committee for our leadership. I will be happy to assist in any way in future. Thank you very much. All the best.
Thank you, Dr. Deepak. Now, please join me in greeting Dr. Hussein Al-Ahmed, Vice President of Academic Affairs at the University of Dubai, as the Chair of the IEEE UAE section.
Good morning. Need to change my glasses. Distinguished guests, ladies and gentlemen, it's my distinct honor and privilege to welcome you all to the IEEE GreenTech Sustainability and Net Zero Policies and Practices Symposium, hosted by the IEEE TEMS Society. As the chair of the IEEE UAE section, I am thrilled to see so many distinguished individuals gathered here today, especially during such critical moments as COP28. This symposium holds immense significance, serving as a platform where the brightest minds from various fields converge to discuss and deliberate on pressing issues of our time: sustainability, green technologies, and the pursuit of net zero policies and practices. The fact that we are convening in Dubai, a city of innovation and commitment to sustainable development. Allow me to share a few statistics that highlight the vibrancy of our IEEE UAE section. We have around 1,800 members. 24% of our members are females, and we have 207 senior members, 6 fellows, and the interesting things, 840 students, because the students are the future of the IEEE. Also, we have 12 active chapters. The last chapter is the TEMS Society chapter. As we gather here during COP28, the challenges before us are enormous, but so are the opportunities. It's our collective responsibility to chart a course towards sustainable future, one that harnesses the power of technology, innovation, and collaboration. We will be immersed in engaging discussion and the sharing of new ideas. I encourage each one of you to actively participate, exchange ideas, and forge partnership that can translate our discussion into tangible actions. Finally, I would like to inform you that why COP28 came to Dubai. Because in Dubai, at the University of Dubai, we have achieved net zero. And we are the second university in the world which achieved net zero. Now, the question is, how did we achieve that? Exactly what Professor Deepak said before, because of technology. Because we are using IoT, we are using smart campus, and we managed to achieve technology plus by using solar panels. So thank you very much for coming to Dubai, and please enjoy your presence at Dubai. And if you have the chance to visit our university, please do so. Thank you very much.
Thank you, Dr. Hussein. Dr. Ravi Kran, the CEO and co-founder of Pneumocity Technologies India, as well as the global president of the IEEE Technology and Engineering Management Society, will be our next estimated speaker.
Morning, chairs, esteemed guests, and also the TEMS BOG members. It's nice to see all of you here. Welcome to the conference on GreenTech, sustainability, and net zero policies. I think it's first of the kind we have started, so I would like to congratulate the organizing team, steering team to put this event together. And it's also timed well. It's in conjunction with COP28, which is happening here, which makes it very interesting to have this event here in Dubai at this time. I wanted to say a few things about our society, IEEE Technology and Engineering Management Society. I'm quite sure you all know IEEE, and most of you here in the audience would also know TEMS. It's a 70-plus-year-old society, which is society with a difference in IEEE community. IEEE morning I was discussing, and usually it is seen as EEE or something related to electrical or electronics. But as you know, IEEE is a global society with more than 400,000 members around the world, and across 40 different societies are looking at interest areas where IEEE is involved in. Our society, TEMS, is a little different because we are looking at the horizontal aspect, which is cutting across all technology areas, how to manage technology, how to manage engineering, how to manage innovations, how to even enable entrepreneurship. So we are looking at a kind of a management aspect, cutting across all technologies and helping people who are transitioning from an engineering role to a managerial role or a leadership role, to give them the right skills, right perspectives to be able to manage these technologies. Like I said, we are 70-plus-year-old now. We were earlier called Engineering Management Society, but over the years we have changed names into Technology Management Council, and now we are called as Technology and Engineering Management Society. Totally, globally, we are around between 2,500 to 3,000 members. It changes a little bit during the year, but that's the size of our community. We have people across the world, a lot of people in the US, Middle East is now becoming also very active. We have, I think, Dubai started a chapter just recently, Dubai University. So I think that's also very happy. A lot of society and members in India, in Asia. I think we have many in Singapore, in Australia, and Japan. So kind of our membership is spread around the world, and we do quite a few activities cutting across various technologies. Like I said, we are not with one technology, we are looking across many technologies. Our publications are our biggest assets. We have transactions on engineering management and engineering management review. These two are very well cited and well reputed magazines. So on the academic side, if you are publishing your papers, I would request you to submit it to us. And if it is cutting across technologies or the managerial aspects, we would really love to get a look at those publications. Tariq, who's our VP of Publications, is here. If you like to network, meet to him, I think he's here. He's also the keynote speaker after this. Would encourage you to have a word with him. And with members, we do a lot of activities in each region. Like this is one of them, and we have one coming up on Monday, GCAIoT. I think that's another flagship one. We are in the 5th year now, Mohammed, or 7th year, sorry, 7th year. So that's another event which we have brought here along with COP. Similarly, we have one coming up in India. I think it's week after next. I think we have it in Bangalore. We have many events and conferences across the world. We are trying to keep it spread wherever our members are, wherever our communities are. So if you're interested in participating as a speaker, as publishing your papers, would encourage you to have a conversation with us, have a look with us. We also do quite a few activities with focused activities. We call it technical activities. So if you're interested in a particular area and you would like to contribute, again, very happy to engage you in the activities. So we do a lot more things, so would not take more time on it. We are all here, the whole TEMS board members. Many of us are here in the audience. If you have time, please talk to us, network with us. Would love to get you engaged. Would like to see how we could contribute and help you in this region. Few words on sustainability and net zero. I think this has been the theme for this year, this week rather, for this week and next week. A lot of people around the world here in Dubai talking about it. A lot of announcements being made. One thing which caught my attention, I've been at COP28 for a couple of days now, is a nice catchy phrase which was put in one of the banners there, which said, "Turn the rhetoric into results." I think we are all talking about it quite a lot. I think it's very, very important that we do something about it and we actually find the results. It's not just doing it, find the results. I think that really got onto my eyes because we are all talking, and what do we make to make things happen? In my professional work, I'm involved very deeply in some of these topics. So I help in across the world in transitioning into clean mobility. I wouldn't call it green mobility at this moment. It's a cleaner mobility. And some of the topics which is always of challenge there for us is it sustainable? Is it really a clean energy? Because energy, I think Deepak mentioned one of the graphs that how are we doing in terms of energy? Is it clean? Many countries are looking at renewable and clean energy to be part of their energy mix. At this moment, it's varied between 5-10% to 30% in different countries. All are targeting as part of the green technologies and clean energy in the next 10, 20, 30, 20, 40, 50 to cross 25%, reach close to 50%. I think that's a big target to have. And I've seen many countries moving towards it, increasing their solar capacity. I think even in Dubai, we have a lot of biggest solar installations here. Renewable energy is growing in a big way. That helps in transitioning into a clean mobility, whether you do it with electric vehicles or whether you do it with fuel cells. One of them will take us towards clean mobility. If you actually look at Dubai, there are a lot of electric cars now. Electric vehicles, bikes, cars are all coming up. It's still a small percentage, but the idea is over a period of time, with the energy mix changing into a cleaner energy, moving towards one of these technologies will make the urban cities cleaner. That brings to the next topic in the conference, which says, is it net zero? I mean, you're moving towards it. Is it really net zero? Right now, not. because from the battery manufacturing to the car or the vehicle manufacturing, it's currently not net zero. I think that's what all companies are looking at, how to move towards a net zero. Can I have, when I use the whole ecosystem, I'm a net zero. Like I said, energy mix is not clean, the battery tech is not clean, the afterlife of vehicles is not clean. So those have to be sorted out before you call it clean or green. I think that's extremely important. And I think that is a focus of most of the countries now. The reason why transportation takes most of its importance is 25% of all pollution on road comes from transportation. All in all cities comes from transportation. Out of that, 60% comes predominantly from vehicles on the road, which is cars and trucks and bikes. These are the ones which are polluting. And it's very important that we change an X percentage. Each country has its own goal. Goals are between 2050, 2040, 2060. Each city, each country is setting its own goals. But the idea is, can we convert a portion of it or a good percentage of it into a cleaner mobility? Is the cleaner mobility only battery electric, or is it fuel cells, or is it an alternate technology? It will be something we will figure it out. I think that's where the technology is of help. But definitely this has started. And we heard about doubling the efficiency and tripling the renewables. I think this is something every country is trying to do. And directly or indirectly, it affects how the clean mobility works. I think that's in that angle, it's extremely important what each nation is pledging into in COP28 here. And I would like to, on this topic, really remember these words that convert rhetoric into results. I think that's extremely important. And here we are a community here, we are talking in terms of technology and various aspects from both academic and industry perspective. And I would request everybody in the audience and whoever is involved to really look at how to convert these into results and how can we put set targets or timelines by which we get these results. And TEMS, just to bring back, TEMS is a society which can help you in some of these conversations, in some of these topics, because we are looking at cross technologies, cross domains, and we would be very happy to contribute as a community, as a think tank, to help in some of these conversations, to bring them in some events, and probably have more conferences, publications, where we can assist, help in each one of these regions to make this transition happen. With that, I would like to stop, and all the best for this conference. And thanks for everybody who's contributed, participating into this conference. And I wish all the very best, and look forward to meeting all of you during today and tomorrow. Thank you.
Thank you, Dr. Ravikran. The keynote speech for today's event is titled Technological Innovation for Climate Change, Mitigation and Adaptation, a Departmental Methodology and Case Study. Allow us to introduce Dr. Tariq Samad, who holds the estimated Honeywell Chair in Technology Leadership Institute located at University of Minnesota, USA.
Thank you. It's a pleasure to be here, and thank you for the organizers for the invitation. Good to see a good representation of the world sitting here, academia, industry, local people from elsewhere, cutting across different technologies and domains and disciplines. My title is quite a mouthful, as you can see: Technological Innovation for Climate Change, Mitigation and Adaptation, a Disciplinary Methodology and Case Study. So I hope I can live up to that long billing. Just to give you a bit of an outline of how this presentation is going to go, I'm going to give you some background and motivation to explain the title partly, and how we came about to do this work. It's actually been quite a collaborative effort that I'll be talking about. Then I'll just briefly review some key facts and figures about the climate change challenge. And I'm sure you know much of this already, but I did want to set the stage for what I'm going to talk about next, which is what this means for technologists, for scientists, for engineers, for people in all facets of technology. And I'm going to discuss a particular case study from the control systems side, because I've been very involved in that community, and we put some effort over the last couple of years into developing something like a roadmap. It's a little too ambitious, perhaps, to call it quite that, but heading in that direction. Then I also want to kind of bring it back that it's not just a technology problem. These are issues that we have to address with technology, certainly, but we have to do it in the societal context. And what does that mean exactly? And again, not won't talk a whole lot about that, but we'll pick some points there. And when we did this work in this particular control systems community, we were doing it for the community. But as we look back on what we did and the process we followed, the methodology we came up with, I think there are lessons to be learned. Not that we did it perfectly, and I can think about things that we could have done better ourselves, but it's kind of a model for how other communities, other disciplinary communities, could think about getting a handle on what they can do to address this crucial, important planetary problem that we are all faced with. Okay, so I've kind of said most of what I say in this slide. So let me just move on and tell you a little bit about how this work started. So this was done under the aegis of the IEEE Control Systems Society, and it wasn't an effort that was solely devoted initially to climate change. In fact, the society decided 2 or 3 years ago now, and started in 2020, to initiate this project, which they called a roadmap for societal scale challenges. So cutting across many things, right? It was led by Anuradha Anaswamy, Karl-Henrik Johansson, and George Papas. Okay. And climate change mitigation and adaptation was one of many topics covered. And I and Professor Pramod Khurgaonkar were the co-leaders. We were asked to co-lead that particular facet, that particular sort of vertical of that discussion. It ended up being the first significant chapter in the report that came out. Then we recruited a number of other contributors from around the world, representing different aspects of both the research and the application of control systems. I want to read their names to you. Saurabh Amin, Aranya Chakraborty, Fabrizio De Bene, Amritam Das, Masayuki Fujita, Mario Garcia Sanz, Dennis Game, Gabriela Hug, Maria Illich, Evan Mirils, Kevin Moore, Lucy Pau, Akshay Rajans, Jakob Stostrup, Junaid Zafar, and Margaret Bauer. So we had a lot of work that we had to do, and we started 2 years ago, more than 2 years ago. We, in fact, held, there was a virtual workshop that was held, and we followed that up a year later with an in-person workshop in Stockholm, where for this entire effort, 60, 70 people were brought together, and we had breakout sessions specifically on the climate change and climate change topic. Many Zoom meetings, many emails, lots of drafts and revisions, and the work is not done yet. We came up with a conclusion and a report that we're actually quite happy and I would say proud of, but that's still in Ravi's words. That's still the rhetoric in a way. The results have yet to be seen. This overall roadmap document is available on the web at that URL, the chapter 2 of that report, and we've submitted an expanded version for publication as well, which I think will appear early next year. I'm happy to supply you these documents as needed too. Right. So that was the background for this work. What makes this so challenging, right? I mean, so let's take a step back and think about when we say climate change is an existential threat to humanity and the planetary ecosystem, which is something I've sort of fervently believe, and you'll see me say that later as well. Why is it such a difficult problem to get a handle on, right? So here are a number of issues that we have to always be thinking about. First of all, it's not just one area. It's not just homes or buildings or industry or transportation. It's diverse sectors across the economy, across society, across industry, all of which have to be dealt with, right? It's not any one technology or a small subset of technologies that have a role to play in addressing these issues. Virtually any technology that we can think of, any field of science and engineering has a role to play. Of course, we need to mitigate greenhouse gas emissions, CO2, methane, other greenhouse gases as well, and more aggressively, because we aren't progress at the rate we need to be making. So more and more aggressive, we have to do that. But at the same time, we also have to recognize that we are going to have to live with some significant level of climate change. And so it's not just a matter of mitigation, it's also a matter of adaptation and resilience. So that also has to be kept in mind when we think about, from the point of view of any particular technology area, what can be done to help us live in a sustainable future. Multiple timescales concerned. Not everything can happen immediately. We want to go to 100% renewables. We can't turn the whole energy ecosystem and supply chain can be turned around on a dime. It'll take time to do that, right? What is the time scale? What should be being done when? So as we think about the urgency of the problem and solving it, we have to start thinking, and again, to repeat something that Ravi was saying, we have to think about roadmaps and milestones and timelines. Those are crucial. And then, of course, it's a matter of not just technologists. It's not a matter of doing research. There are communities involved, there are stakeholders around the world. These stakeholders are in many different kinds of geographies and ecologies. They're being affected very differently. Some are in wealthy countries where they can afford to deploy climate change mitigation technologies. Others are in poorer countries where they are subject to the climate change without having the resources to adapt to it. So we have to keep that in mind as well. And really, it's something of interest to humanity and the planet. Okay. So a couple of charts from that I expect many of you have already seen. This is from IPCC, the latest IPCC report. And the reason I'm showing this is to again reemphasize this notion of how broad this problem is in terms of the sectors of the economy that are involved. And I like how IPCC has done that, and speaking to the choir here to some extent. We can think in terms of emissions by sector, right? So for example, that's the top chart there. And you probably can't read it in the back, but the left-hand block of that says building 6%. Okay, so if you were to just look at that chart, and that says that 6% of global greenhouse gas emissions, CO2 equivalent, are generated by buildings of various sorts, right? All right. And then it's transport 15%, agriculture, forestry, and other land use 22%, industry 24%, other energy 10%. Then there's that electricity plus heat bar, which is 23%. But where is that electricity and heat going? Well, a lot of that is going into buildings, right? So we have to distinguish between these direct emissions, which can be misleading to some extent, and the indirect plus indirect emissions. So in fact, almost half of the electricity plus heat bar is actually going into buildings. So the fact that we use electricity in buildings, buildings are not creating greenhouse gas emissions directly by using that electricity, but the electricity is being generated somewhere else, and it's being brought into the building. And so we need to account for that in the building sector as well. So let me read this quote to you, which again reemphasizes this notion about the sectoral diversity. All global modeled pathways that limit warming to 1.5 degrees Celsius within a 50% likelihood, or greater than 50% likelihood, with no or limited overshoot, and as well as those that limit warming to 2 degrees Celsius, which is already getting quite scary, at greater than 67% confidence, involve rapid and deep, and in most cases, immediate greenhouse gas emissions reductions in all sectors this decade, right? All sectors and starting this decade. So some indication of the breadth of this challenge and the timeliness of it. And the next chart I want to show you is more specifically on energy, right? I mean, of course, greenhouse gas emissions come from various sources. Energy is one of them, the predominant one of them. And so we have to think about what can we do on the energy front. And so the International Energy Agency has come out with a roadmap for how to get to net zero in energy by 2050, right? And they came out with this. This is from this year. They updated a roadmap from last year, specifically after the Russia-Ukraine war started. And it's really interesting to see, right? At the bottom, we're going to get to net zero by 2050. Well, what is it going to take? We have to think in terms of what can be done when, which technologies are more advanced, which are less advanced, will have more resistance from various sectors. And this is, I mean, it almost seems as if this is, too unlikely to happen. I think it's just very, very aggressive. It's not going to happen this way, but it's still showing us what needs to happen if we really are serious about these goals, with timings and specific milestones associated. So again, you can't read it everywhere, I'm sure. So on the top, by 2025, nearly 50% of electricity has to come from low emission sources, right? And no new sales of fossil fuel boilers. So all sales of fossil fuel boilers, oil and gas boilers, are banned, basically. That's what, by 2025, by virtually within 2 years from now. By 2030, 8% of emissions from cement production captured and stored, right? I mean, cement is a sector which is very hard to electrify. It relies on fossil fuel heating for the production. And so we need to be able to somehow address those issues, because we do not think that in the foreseeable near future, at any rate, we will be able to electrify that and make that production of cement clean. And yet we need cement for so many things. So the alternative is capture the emissions from those, the carbon, the CO2 equivalent emissions. Also by 2030, 60% of global car sales electric, right? 60% by 2030. 720 gigawatt electrolyzer capacity. So this is talking about the need for having more hydrogen production. That's another way we can address problems like industrial use in hydrogen, right? So 720 gigawatts, which I don't actually know what the number is right now. I think it's in the tens of gigawatts worldwide. Not sure about that though. 2035, no new internal combustion engine car sales. 3 gigatons of carbon dioxide capture. So we have carbon dioxide capture and sequestration technology implemented to the point where 3 gigatons have been captured. Today, we talk about, there are a few sites that are capturing millions of gigatons. So we are now talking gigatons, right? I won't go through all of these. Let me just drop down a little bit. 2045, 50% of heating demand met by heat pumps. Right? Where is heating demand coming from? How is that satisfied now? Largely by oil and gas, right? And if you live in a place like Minneapolis, which is where I live, which is the coldest city in the US, coldest big city in the US, every home has a boiler that's running on natural gas, or some people still are using various other sort of fossil fuels as well. So 50% of heating demand met by heat pumps. The technology is in a sense there, but it needs to be commercialized, needs to be made more efficient. It needs to address cold weather climates as well. And then by 2050, almost 4 terawatt electrolyzer for hydrogen production, and nearly 90% of electricity from renewables. That's what we're going to take, and this is the pathway that's going to be involved. Okay. So now let me switch gears and talk a little bit about control systems, but I will really do this from the point of view of the domain itself, these various domains itself, as you'll see. But first of all, let's just recognize that there are so many technologies that are relevant here, and I've just listed several of these, right? And I'm not going to be talking about all of them, but I'd like to think that some of the process we followed, the methodology we came up with, aspects of that would be relevant to people who want to do something similar, map out opportunities in any of these technologies or other technologies as well. And I'm really going to be talking about control systems. Just to start with, though, what is a control system? What does it cover? And so this is kind of what, if you were to ask a control engineer, tell me something about what control systems do, right? This is the sort of thing you would come up with. Feedback control, feed-forward control, automation, that's an aspect of control systems. Modeling and simulation. The world is a dynamical entity, right? And it's the control systems community that understands how to manage dynamical systems and how to control them. System identification, which is modeling based on data. Dynamical systems, the repository of the dynamical systems expertise in many ways is the control community. Monitoring and diagnostics, optimization and decision-making, distributed and decentralized control. And then control systems rely on many other technologies, whether it's Internet of Things, or whether it's advanced sensors, or whether it's analytics, or whether it's digital twins and other things, right? Okay, so when we started to think about, well, from the control systems point of view, what does how can control systems help with meeting this challenge of climate change, right? And it took us a while to get there, but we ended up saying, well, we need to think in terms of domains, right? And we came up with ultimately 14 domains. I'm showing them in 2 batches here. So here's the first 7 of them. Electric, and some of these, 3 of these, in fact, I'll go into just a little bit more detail on subsequent slides, so I'll skip over them in this overview. Electric energy systems, that's different than just electric power generation, which I'll talk about next. But electric energy systems means smart grids, the whole sort of how do you take electricity from generation sources, put it to the consumer, whether it's buildings or industrial or residential consumers. Of course, we want to go to more and more renewables, right? And these renewables are intermittent and they are more decentralized. Well, how do we bring it all together? How do we still ensure reliability? So the energy system, the grid itself is part of that. And then when we think not just about energy from wind and solar, but electricity from hydrogen, that brings its own complications in terms of the systems aspect. Transportation, and this covers, I mean, each of these bullets actually cover a lot of depth between in them. So in transportation, we mean roads, we mean rail, we mean shipping, we mean aviation, right? We cover all of that, and the solutions are different in those different cases. Of course, there's so much interest now in electric vehicles, and there's been good progress, although it needs to be much better progress than we have made as yet, but at least things seem to be moving in the right direction. But what about aviation? What about shipping, right? So then we have to think about other ways of powering, other clean ways of powering those transportation systems. Homes and transportation, I also mentioned, by the way, the whole vehicle to X technologies, right? So if you have a vehicle, which is battery powered, perhaps it can also power other things that need to be powered. It could start addressing adaptation issues then. So if you have a storm and the grid is knocked out in some part of the city, well, maybe these mobile battery packs, as it were, could go and provide power there, right? So they're always keeping, and we were always trying to keep both the mitigation and the adaptation perspectives in mind. Homes, building, and facilities, that includes microgrids, that includes demand response, that's part of that. Industry and manufacturing, I'll say more about that separately. Data computing and communication is actually an interesting topic. And when we first started putting this together and looking at some of the sources, it was really quite scary how much growth there is happening in computation and communication. And I'm trying to recall some of the numbers here. 20-fold increase in internet data over the course of a few years, some years ago, 30-fold increase in something else, right? And so it seemed really scary. Think about how much electricity is being consumed in cryptocurrency mining, right? But as we looked into it more, it's actually not as bad a problem as we thought it was, because efficiency has improved, even though from the numerical point of view, it looks like things are getting worse, and they are getting worse. But efficiencies have improved dramatically, and a lot of the energy being used in these cases is renewable energy, because there are now renewable sites that are sort of co-located with data centers, for example. So in fact, energy use in our emissions increase for some of the for this sector is somewhere around 1 to 2% a year. It's still increasing. We would like to decrease it, but it's 1 to 2% of emissions increase versus 10, 20, 30 or more percent in terms of the increase in communication and computation. So not as much of a concern as we first thought. On the other hand, the hydrogen ecosystem is the opposite story. I think the recognition is growing that it is actually more and more important, and we need to put more and more effort into it. So obviously green hydrogen, where the hydrogen is generated by electrolysis, is the preferred option, but that's still very expensive. And of course, you have to make sure that that electricity is coming from renewable sources. So there's also a lot of interest and requirement for blue hydrogen, which is getting the hydrogen from natural gas from the methane molecule, and then capturing the CO2 and sequestering it. And there are various other colors. There are 6 or 7 colors of hydrogen as well. And the renewable fuels comes in here too, because hydrogen is not just used for heat. It is also very effective as a feedstock for ammonia and for e-methane and for some other fuels as well. Then we turn to food, the next set of 7 domains, food and agriculture, and we can put water perhaps in there too. They all have many aspects to it. You know, an interesting thing about food is there's a supply chain problem which has a dynamic to it that many other supply chains do not have, and that dynamic is the perishability. So you have to keep that into account if you want to think about applying optimization and control technologies. Infrastructures and communities, and this is a topic that's more squarely focused on adaptation than on mitigation, because we need to think about how to design and how to operate infrastructures that can help communities deal with the adverse impacts of climate change, right? Negative emissions technologies. This is pulling CO2 out of the air, which there's actually a lot of interest in, a lot of startups. Some of them seem very promising. I'm personally very skeptical about this, because just the techno-economics of just taking CO2, which is at very low concentration, very low pressure in the general atmosphere, and extracting it, and has to be done on a global scale on top of it, just seems too challenging compared to, for example, point source CO2 capture, like capturing the CO2 as it comes out of a natural gas or coal-fired power plant, which is an easier problem, still very difficult, still not anything widely commercialized, but at least there's some trial commercial things happening there. Geoengineering is a topic we thought of initially we deliberately wanted to exclude it. What is geoengineering? Again, many of you have heard about it, but this means changing the planet so that to address global warming in various ways. So one idea is solar reflective arrays, unfurl large mirrors in space in the upper atmosphere to reflect sunlight back, right? And that would keep the sunlight from hitting the earth. Another idea is ocean seeding. So throw lots of iron filings into the ocean so that they can absorb the CO2, turn to rust, and sink down. So people have been proposing ideas like that as kind of a last resort. And even as a last resort, it seems too scary, because how can we really have any assurance that these things will be safe, right? But then finally we said, well, this is happening, and part of the role that we can play in the controls community, particularly given our expertise in dynamical systems and understanding highly uncertain dynamical systems, and is that we can sound the alarm bells where they need to be sounded. Environmental monitoring, kind of obvious what that means. And socio-technical systems, I'll say some more about it as well. So in each of these cases, we had some discussion, we documented it, identified salient aspects, identified various interdependencies, because there are lots of interdependencies amongst these 7 topics. They arise in particular because of the drive towards electrifying everything, right? So when you think about electrifying transportation, well, that connects electric power generation, the electric power system, and transportation, right? And similarly with many of these cases. All right, so we also had a person in our community who's a professor in the UK, who's also an artist, so she came up with a nice graphic as well, and actually visuals are just so important. So something like this certainly is worth more than 1,000 words, I would say. It just covers the space, right? Talks about all these different aspects of society and industry and economy that are impacted by climate change, that control technology can develop. And here are some of the pieces of control systems that would be relevant here. To give you a couple of examples. Electric power generation. Of course, we know it's an urgent priority to replace fossil fuel-based electricity production with renewable generation. Right? But we also know that the ramp down of fossil fuels cannot happen instantaneously. So we have to think about how do we have more efficient, to go back to the importance of energy efficiency, how can we have more efficient plants, or how can we do carbon capture for fossil fuel power plants? It's been really dramatic to see how much costs have reduced in solar and wind generation. We've actually reached cost parity with natural gas, and certainly much cheaper than coal already, but even with natural gas, we've reached cost parity in many cases, and sometimes, depending on the locations, even lower costs now. But of course, this all has to be brought up to scale too. There are other green energy options as well: geothermal, marine, riverine hydropower, that are being actively explored as well, that are very promising too. Nuclear energy, for a long while in the Western world, we were backtracking on nuclear energy. Now, again, we're starting to recognize the importance as a clean energy source of doing this. Of course, keeping in mind that safety is of prime importance here. So topics like small modular reactors and all the research that's going on in fusion seem like really, really exciting developments. And all of these, control is needed for all of these. So that's why it's so important within this community. So I said in each case, we identified 3 example opportunities. And, you know, in each case, we could have probably have identified 20 example opportunities. And we just ended up saying, well, just to keep things manageable, we just say 3, and we won't even say that they are the 3 most important opportunities. They're just 3 examples. And others can think of other examples, right? But just to make things a little bit more actionable in terms of what can be done from the point of view of the research and development community. So example opportunities: dynamic management and optimization of large-scale renewable energy generators. An example of that is wind power, but not a wind turbine, but a wind farm. When you have a wind farm, there are interactions amongst the turbines, upstream, downstream interactions, that if you are careful about how you control those individual wind turbines, you can be much better at ensuring that you capture more of the energy from the wind. So that's kind of an example of that. Control co-design for floating offshore wind, tidal, and wave power generators. This control co-design area is something that we highlighted in quite a few cases. And the idea here is that you need to not think about control as something that's developed, the control system that's developed, the control architecture, the control methodology is developed after the system has been designed and constructed. Instead, control has to be integrated in that process, so co-design there. Lastly, optimization of coupled cross-sector electricity generation, including hydrogen and biofuels. A second example, industry and manufacturing. So about 34% of global greenhouse gas emissions come from power and heating. But the thing is that these are all coming from many different, within the sector, there are so many different kinds of industrial and manufacturing plants. And in order to figure out how to reduce their GHG emissions, you have to have pretty deep expertise in those plants. So you need to understand how cement is made. You need to understand how steel is made. You need to understand how chemicals are manufactured, how paper is produced, right? And so it's not like one Band-Aid can solve all of these issues. And some sectors, as I mentioned before, like cement, are particularly hard to electrify. So there's a real drive towards circular economies as well. Again, going back to this notion of efficiency and reducing waste and reusing. Inherent feedback loops in all these industrial plants that are really important. So again, that's a sweet spot for control. And certainly Industry 4.0 is a big enabler in this case. Example opportunities: advanced process control, optimization, and data analytics over the manufacturing value chain, keeping sustainability in mind. Control co-design, here's the co-design topic again, for greenfield net zero projects, leveraging Industry 4.0 enablers. And the last one, process design, control, and optimization for monitoring, capturing, and storage of greenhouse gases and for utilization of captured gases, right? We recognized early enough in the process that we cannot just think in terms of technology development, that we have to think about the societal context. And we had a separate set of discussions around various topics related to societal impact and that sort of what does that mean? But then we also realized that that technology itself has a role to play in thinking about how technologies can be developed with societal needs and the societal context in mind. And again, it's because in the case of control systems, there's so much uncertainty. They are hard to model. There are dynamics involved. And in order to address all of these things right, you have to apply some of this algorithmic and modeling approaches that we are quite familiar with. Yeah. So there are system theoretic problems, there are multi-scale dynamics, this pervasive uncertainty, there's feedback effects. This is all very happening in a very distributed fashion. How do you get a handle on all of those to do these things right, so that you don't make things worse than they are already, right? A lot of interconnections here among critical infrastructures and societal imperatives in particular. And this can also be related to systems thinking, right? And which is an offshoot of control itself. So it's kind of adopting that system thinking umbrella more broadly. So anyway, we have three things here as well. Maybe in the interest of time, I want to go through them. And so in each of these 14 cases, we came up with these three examples, and then we created a graphic which puts out all of these example opportunities. And the left column is short-term opportunities, middle column is medium-term, right-hand column is long-term. We had some idea about a short-term means by 2030, medium-term means between 2030 and 2040, and long-term means by 2050. And from a researcher's perspective, it's very hard to think in terms of this kind of timing. We really had to push the community to sort of get them to think in terms of, it's not enough just to say we need to do this. You have to have some idea. We know it can be precise, but you have to have some idea of how difficult it is to do. How long is it going to take? How many intermediate steps are involved? And because we really do need to have a roadmap in mind, even though anything we put together as a roadmap will probably not be exactly followed. So then finally, or not quite finally, the broader perspectives. And this is really recognizing that these are not just science, engineering, or technology problems, right? People are involved, and people are involved in many different ways, and we have to think about many different aspects here. So sustainable economic growth, I'll say a little bit more about that. From research to large-scale deployment, right? I mean, if you're a technologist, you're doing the research, you're coming up with your new theories and algorithms and models and simulations, you're testing them in simulation or on a pilot plant, perhaps a best case. Well, that's just part of the story. You still have to think about ultimate deployment. And if you think about, okay, let me finish my research, then I can hand it off to somebody else who can take the next step, then they can hand it off to somebody else. Ultimately, something else will happen. Then we can get the policymakers involved. It's going to take too long. We don't have that time. So it has to be sort of a really close integration between all these sectors and all these stakeholders to make all of this happen. Education and awareness is a big part of the challenge as well. And it's at multiple stages, undergraduates, graduates, perhaps pre-undergraduates as well, just in terms of getting the public more broadly aware. Equity and social justice, as I mentioned already, who's being harmed by climate change? It's people, for the most part, people who have had very little to do with the mess that we found ourselves in. And it's too easy to come up with solutions if you're not thinking of this broader societal context and think, oh, this will work great, right? So we have electric vehicles, we'll put subsidies on them and just let them be offered. And well, the people who can afford them, even with the subsidies, are the richer people in society, not the poorer people who are more affected by all of these problems. And really a need for collaborating across multiple disciplines and domains. So, sustainable economic growth, when we talk about that, it's again to recognize that there is this interplay between society, the economy, and the environment. I think I've said really most of this already. We need to go from this model of growth at all costs. That's what the ultimate good is. How fast are we growing? That's what matters. How fast is GDP growth? We have to think in terms of it's not just enough we have to realize it's not enough to think just in those terms. We have to think also of regeneration, reuse, circular economies, taking care of the planet while we grow. Finally, let me just share some thoughts for those of you who might be interested in doing something similar along these lines, right? So first of all, leadership is important, right? And in this case, it was Pramod Kurgonikar and I, and we were asked to do this, and we both had been part of this community for decades. Actually, I'm a past president of Control Systems Pramod Kirgaonkar is amongst the top researchers in the field. We were also both really deep in studying climate change and had been looking at it for decades ourselves. And we did have some kind of a shared vision, and I think we were able to get the right people involved because of that. Don't just think in technology terms. Keep the societal context in mind, right? Don't organize your thinking in terms of your technology discipline. We could have said, okay, control systems, that includes feedback control, it includes modeling and system identification, it includes optimization, it includes distributed control. Let's see what can be done in each of these areas. And there was some talk about going in that direction. But then we said, this is not the right way to think about it. We need to think about it in terms of the problem space, right? So that's where we decided to look at buildings and industrial facilities and agriculture and negative emissions and all of that. Estimate time horizons for impact, right? Even though that's such a challenge, and I think we could probably have done a better job on that if we had more time. Engage experts in the relevant fields, and not just from a theory point of view, because we also need to think about the applications of people who can have some familiarity with that as well. Of course, you have to standardize these things, because we had people contributing in each of these areas and in multiple different ways, and we had to think about how to standardize it. We actually iterated on that a few times and finally had to make some hard decisions as well. It's a long horizon process. We've done the first stage of our work. We've put this report out, but now we have to carry it forward as well. And so we have to make sure that this is sustained. And actually part of what we think, both Pramod and I, is we have to get some more younger people involved to help champion this forward. We are probably not going to be around long enough in the community to see the impact that needs to happen. And one other thing to mention, who are we doing this for, right? And so we thought about this as well. And these are three stakeholder communities that I would say are the ones to really think about targeting. And I'll mention to you what's missing in here, right? But first of all, students and early career researchers, they are the ones who are still at a stage where they can devote careers to an area which will be required in many of these cases. Professional organizations like IEEE Control System Society, there are a number of other ones as well, because they have the resources to promote this going forward. They can put out reports, they can organize conferences, they can publish new journals, right? And funding agencies, because they're the ones who can provide the resources for this research. What's missing is people like me, people who are already senior level researchers or senior level technologists. It's too late for us, I think, much of this. So we need to be thinking more about people who are coming up. Yeah. So I think, again, I've said most of what's here already. Just to reiterate the bullet here, research as usual is not an option. We need to solve things too rapidly. We need industry and government partnerships, policymakers, government people to be individuals, industry folks to be involved at the same time. The societal perspectives have to be respected, and really no technology can do this in itself. No discipline can do it by itself. And we hope that what we've done can help some other disciplines chart a similar path too, and perhaps we learn from their experiences as well. So thank you for your attention, and happy to answer any questions or take them afterwards in the coffee break. Thank you.
Thank you, Dr. Tariq Samad. We are about to start a networking break, which offers a great chance to meet other attendees, share knowledge, and develop successful collaboration. Please enjoy.